All right, guys, sorry that kind of cut us off. So, I had determined that our smallest amount of moles that we had between carbon, hydrogen, and oxygen was indeed oxygen. So, I used the amount of moles of oxygen to come up with our divisor, which gave us a ratio of 1, 1.33, and 1. Now, 1.33 is not near a whole number. So what we need to do to figure out how to multiply it by something to get it a whole number. Now, hopefully you understand what your decimals mean in terms of a fraction. So 0.33 as a decimal is a third. So I'm going to multiply everything by 3 because a third times 3 is 1, right? So if I multiply 1 times 3, I get 3. If I multiply 1.33 by 3, I get 4. And if I multiply 1 by 3, I get 3. So our simplest whole number ratio here would be 3 carbons, 4 hydrogens, and 3 oxygens. So our formula here for empirical would be C3H4O3. Now, the next thing we have to do is come up with a mass for that empirical formula. So if I come up with an empirical formula, mass, 3 carbons, 12.01 times 3, plus 4 hydrogens, 4 times 1.01, plus 3 oxygens, 3 times 16, I get an empirical mass of 88.07 grams per mole. Now, does that match our molecular mass that is given to us? No, it does not. So the next step then is to figure out how many empirical units there are in each of the molecular units. So I'm going to take 180 grams and divide it by 88.07 grams to figure out how many units I have. So when I do that, I get 2.04, which is really, really close to 2. Remember, it's still within a tenth. So that means I have 2 empirical units in my molecular unit. So I'm going to need to multiply this empirical formula by 2. So 2 times 3 for my carbons will give me 6 carbons. 2 times 4 for my hydrogens will give me 8 hydrogens. And 2 times 3 for my oxygens will give me 6 oxygens. Okay? So this is the molecular formula for the compound that we have. Okay? C6H8O6. Okay, let's do one more. Vitamin D. Your body's ability to absorb calcium is aided by vitamin D. That's why you will see vitamin D fortified milk. Chemical analysis of vitamin D3 yields the data below. What are the empirical and the molecular formulas for vitamin D? Okay, so we have our mass percents, we have our molecular mass here as well. So we're going to start with carbon. Carbon, I'm going to pretend like I've got 100 grams of this stuff, right? So I would have 84.31 grams of carbon. In 12.01 grams of carbon, I've got 1 mole of carbon. So when I do that, that gives me 7.0199 moles of carbon. Okay? Now, for hydrogen, we're going to start with do hydrogen next. I'm going to have 11.53 grams of hydrogen in 100 grams. So in 1 mole of hydrogen, I have 1.01 grams of hydrogen. Okay, so that gives me 11.415 8 moles of hydrogen. And then oxygen. I've got 4.16 grams of oxygen. And in 1 mole of oxygen, I have 16.00 grams of oxygen. So that gives me 0.26 moles of oxygen. Okay, what's our next step? Our next step is to divide by our smallest thing. So our smallest amount of moles of any of these is our oxygen. So we're going to use oxygen as our divisor. So this will give me 1 oxygen, right? And this gives me 43.9, which is super close to 44. And this gives me 26.99, which is super close to 27. Okay, so this gives me 27 carbons, 44 hydrogens, and 1 oxygen. Oops, not carbons, hydrogens here. So my empirical formula is going to be C27H44O. Okay, so if I do my mass here of 27 times 12.01 for my carbons, plus 44 times 1.01 for my hydrogens, plus 16 for my 1 oxygen, I get an empirical mass of 384.71 grams per mole. Now, does that match my molecular mass? Yeah, it does. This matches, doesn't it? So because it matches, it means our empirical formula is the same as our molecular formula. So our molecular formula is going to be C27H44O. That is vitamin D3. Okay, so we just derived that chemical formula for that. Hopefully this helps. If you want more information, we have some more deriving of chemical hydrated compounds. So we can explore that later if we have more time. We'll see you later. Bye.